13, Physical Chemistry I, focuses on classical thermodynamics in Unit I. This unit extends fundamental principles to open systems, multi-component mixtures, and absolute temperature behaviors. Core concepts and theoretical foundations. 1. Thermodynamics of open systems and partial molar properties. For open systems, or systems with variable composition, thermodynamic functions depend not only on temperature T and pressure P, but also on the number of moles, N_1, N_2, dots, N_I, of each constituent. Partial molar property, bar X, _I, represents the change in an extensive property X, such as volume 5, enthalpy H, or free energy G. When 1 texmole of component I is added to an infinitely large amount of the mixture at constant T, P, and amounts of other components. Total value of extensive property. 2. Chemical potential, μ_I. Definition. Chemical potential is defined as the partial molar Gibbs free energy of component 1. Fundamental differential equation for open systems. Physical significance. Chemical potential serves as the thermodynamic potential driving mass transfer in chemical reactions. Matter flows spontaneously from a phase with a higher chemical potential to one with a lower chemical potential until equilibrium μ_I alpha equals μ_I beta is attained. 3. The Gibbs-Duhem equation. The Gibbs-Duhem equation shows how changes in chemical potential or partial molar properties are interrelated in a multi-component mixture. Formulation. At constant temperature T and pressure P, where X_I is the mole fraction of component I. Significance. Partial molar properties in a solution cannot change independently. Altering the chemical potential of one component forces a corresponding change in the others. 4. Maxwell's thermodynamic relations and equations of state. Maxwell's relations connect state variables, P, V, T, S, using exact differentials of thermodynamic potentials, U, H, A, G. Thermodynamic equations of state. 5. Adiabatic flame temperature, defined as the maximum theoretical temperature reached by combustion products when a reaction proceeds under adiabatic conditions, Q equals 0, delta H equals 0 at constant pressure. All energy released during exothermic combustion goes directly into raising the thermal energy, temperature, of the product gases. 6. Third law of thermodynamics and zero-point physics. Nernst heat theorem. As T to 0 text K, the temperature coefficients of free energy change, delta G, and enthalpy change, delta H, vanish. Third law statement. The entropy of a pure, perfectly crystalline substance at absolute 0, 0 text K, is 0. S_0 equals 0. Residual entropy. Non-zero entropy present at 0 text K due to structural disorder or molecular orientation traps in the crystal lattice, e.g., in text CO, text_2 text O, text_2 text O ice. Unattainability principle. It is physically impossible to reduce any system to absolute 0, 0 text K in a finite number of steps. 7. Chemical equilibrium functions. Van 't Hoff isotherm. Delta G circ equals -RT K_P. Van 't Hoff isochore. Key high yield exam topics. Important derivations. Gibbs-Duhem equation. Thermodynamic equations of state from Maxwell's relations. Van 't Hoff isochore. Conceptual questions. Physical meaning of chemical potential. Origin of residual entropy. Condition for adiabatic flame temperature. For a step-by-step mathematical derivation of partial molar properties and the Gibbs-Duhem equation, watch Gibbs-Duhem equation and partial molar properties. This video covers the exact derivations and notes frequently asked in MSc. Physical chemistry semester examinations. YouTube video views will be stored in your YouTube history, and your data will be stored and used by YouTube according to its terms of service.